All right, so I had forgotten to mention in the last one is that the answer is going to be D, E2, because it doesn't form a carbocation, right? And then if that's not clear, go ahead and just let me know. And then I'll go ahead and explain it a little bit further more. But for now, we're going to move right on here to B. So B, we have a, let's take a look at this. Now, you can look at this one and tell that this is a substitution reaction, correct? There's nothing that's really being eliminated. You can just see that this right here is being traded for that, this OCH3 right here. So right off the bat here, we're going to go in, this is 50% of the answers right there. So, I mean, if you got to play the guessing game, well, now you're down to 50%. So that's not even a bad start. So now it's just a 50-50 chance. But moving forward, we're better than that. And we can figure out exactly what this is just by looking at this. And I know that you can. So what we're going to go and do is now the same thing as last one. We just have to figure out, is this going to form a carbocation or not? And like we were talking about earlier, SN2 or anything with a 2, E2 or SN2 is going to form no carbocation. And then this one will have a carbocation. So either of the ones will form a carbocation. Well, what do we look at from here? Well, the first thing that I'm going to look at is this Br, like in the last one, is going to go ahead and leave. Just like what we were talking about earlier, what we were talking about with that, the F being poor at leaving, and the Cl minus, and the Br minus, and the I minus all being good leaving groups because they're weak conjugate bases. And if you don't know what that is, go ahead and let me know, and I'll make a video separately on that. But basically, to wrap up weak conjugate bases is that when protonated, they have a strong acid. So protonated, HCl is a strong acid, right? HBr, another strong acid. HI, another strong acid. The reason why this one's no good, or not a good leaving group, is because this forms HF, which is actually a weak acid. So weak acid on that one for this guy. However, these are all strong. Just to get that out of the way really quick. But yeah, so basically this Br minus is going to want to head out. He says, I'm out. Because he's a decent leaving group. He's not particularly amazing. He's a good leaving group. He's just not, like, he won't shoot out the atom, but he will go. Now he's going to form Br minus, right? Now we're going to do the same thing as last one. We're going to go and look back to our solution here and say, what do we have? So let's go ahead and think about what that's going to be when it's dissolved. And I'll go ahead and give you a second to think about what that's going to be. So what that's going to go and form is that's going to form CH3O minus, right? Because right here it's neutral and it's losing the Na plus atom or ion. And it's going to have the Na plus. And you can see where those two combined would be neutral. So this is negative and this is positive, and what do we have again? We've got this Na plus is going to go ahead and neutralize that Br over here in the end, right? It's going to want, I mean, they're going to neutralize out. You're not going to just have a Br minus floating around in solution where it's not particularly happy. It's going to go and get neutralized, which is perfect. That means it's happy going. It's content with doing that. It's not going to go ahead and revert back to where it just was. Now what do we look at? Well, now we have to look at this part right here. Now we have to look at this guy, this CH3O minus. And we have to say, does it want to shoot into this spot quickly? And that's up to you to decide. And what you're going to look at here is you have to think, well, does this want to make that bond pretty quickly? So you're going to look at, like we were talking about earlier, the hardness and softness of this molecule. Now, this is an O minus. So what you have here is you've got a C bonded to 3 H's and just an O. And it's minus, right? So it wants that last little bond to it. It wants to get one more so it becomes neutral, because O's always want 2 bonds to them, right? Well, that is what makes me lead to thinking that this one is going to not form a carbocation. And the reason being is because when this spot right here frees up, and you've got no Br there anymore, right? You've just got this hexagon and nothing else. This guy's going to want to go ahead and bond there. It's actually going to want that bond because then it becomes neutral. And it's going to get another bond, and it's going to look like this. It's going to have that O, and then it's going to have another bond to it. And instead it'll have 2 lone pairs, making it neutral. So I would say, and it's also negative. That's the other thing, is that this isn't particularly happy being like this. It's not comfortable for it. So it's going to go and shoot into that spot very quickly from the opposite side and form this bond right here. And this is how you get it, CH3O. CH3O, bonded right there in a substitution reaction, because you know it's not elimination 1 and you know it's not elimination 2. And now all we had to figure out was whether it's going to form the carbocation, right? This is not going to want to form that carbocation. That's going to shoot in there quicker than this thing makes a carbocation. As soon as that bromide leaves, this CH3O minus, which is not comfortable, is going to say, dude, give me that bond. And it will take it immediately before this ever forms a carbocation, meaning that this one will be B, SN2.